Hi, Ronnie. Are you there?
Hi, John.
Hey there.
How are you?
I'm good. How about yourself?
Doing good. Do you want to test your slides?
Yeah.
You
All
should
right.
be able to just share over mine.
Okay. Just sent the share request. It told me I needed to request it, so I'll. And it says you're not. Okay, now that sharing is enabled, I will try. Let's see.
It should allow you to share.
Okay. Are you seeing a big.
I'm seeing archival resource key.
Okay, and you see the slide advancing?
hmm
Okay. And you're not seeing my speaker notes.
I am not seeing speaker notes.
It seems like we're in a good shape now. I think I could leave this the current slide on the screen as a
Yeah,
teaser, if that's okay with you.
perfect for me.
Okay. And then how much, just to verify, do I would I'm not sure about the timing. Do you want me to leave some time for questions? Will there be questions? Or if that's
It has you for an hour, and I would leave 10 minutes at least for questions.
right, that's sort of what I was aiming at. And
And typically I just turn my camera back on, and then I'll send you a 10-minute warning in the chat if
yeah, feel
you
free to
don't.
pipe up because I may not, when you're presenting it, I don't always see the chat.
Okay,
Uh,
I
so
can.
maybe I can figure out, I can open it in advance, leave it somewhere. Okay.
You might need to turn your volume up just a little bit. I have mine up all the way and
Oh, thank you for that. Let me check. Zoom is very opinionated about audio. And um, let's see, microphone. I'm turning up the microphone.
oh, you
Is
sound good.
that better?
Yes.
Great. Okay. So I'm going to turn my camera off for a few minutes. That's all right.
Yep. I'm gonna hit mute because my son's calling me real fast.
All right.
Hello, everyone. I am Ronnie Cox. I'm going to be your moderator, and Mary Aycock is going to be our co-moderator for the next two sessions. We're going to get started. I have John Kunze. I know I said that wrong. Kunze in for this next session. He is from Drexel University, is a former Unix hacker who led publications of the first metadata standard, Dublin Core, unblocked approval of the first URL standard by writing RFC 1736, and created Baggett and the ARK identifier schema. John, the floor is yours.
Great. Thank you, Ronnie. Um, Again, my name is John Kunze, and this course was co-developed with Donnie Winston. I'm a computer scientist who has been working with data centers, libraries, museums, and archives for the past 20 years. In Berkeley, California, I wrote software tools that come pre-installed on all your Mac and Linux systems. Then I moved into information systems and preservation standards, where I became the main editor or author of the first three metadata standards, which were Dublin Core. But before that, I wrote the formal requirements that moved that first URL standard over the finish line. Both those topics are important for today's topic. The trick to getting the URL or web links standard approved was to allow or to make it okay for URLs to be breakable, leaving persistent URLs for a future standard. So in a way, um, broken URLs are my fault, and it's my punishment that many years later I'm still working to fix them. Now, in case you're wondering what a persistent identifier is, it serves the same purpose as a permalink. It's meant to persist, but there are no guarantees. So we're talking about URI or URL identifiers that were aspirationally persistent when created. Why should we care about ARCs? The average lifetime of a URL was once said to be 100 days. At the end of its life, a URL link breaks, usually giving you the dreaded 404 not found error that most of us have seen. While that can be irritating, it's a minor disaster for memory organizations. So ARCs can serve as robust links for any kind of thing in any discipline. The ARC scheme is one of 5 so-called persistent identifier or PID schemes. There's been a great deal of nonsense written about PIDs. Some of it is described in a Twitter thread called 10 Persistent Myths About Persistent Identifiers, which is available at the link using this example ARC or the QR code next to it. PIDs are permalinks containing hints that make them look different from the average URL link. Every URL is potentially persistent, but strangely, some people think it becomes persistent when it acquires some superficial syntax differences, such as the arc colon in this example arc, or when you see the domain name doi.org at the start of a URL. The nonsense was in full bloom in the late 1990s, but it polluted the debate about the 4 proposed PID schemes. That is why that's why the Archival Resource Key or ARK identifier scheme was introduced in 2001. So here's what an ARK looks like. At first sight, it's a URL that carries this internal label. To the right, the 5-digit name assigning authority number, or NAN, identifies the organization that created the ARK. Further right, after that number, is the local name of the thing that the ARK is assigned to. To the left, the host name makes the ARK actionable, or something you can click on. It's also known as the resolver. ARKs are unusual among PIDs in allowing organizations to run their own resolvers. The part starting with the ARK colon is the core globally unique identity. It does not depend on the host being available or on the future existence of the World Wide Web. In the previous example, you saw n2t.net, which is a global name-to-thing resolver. This is the main ARK resolver. So why doesn't it contain the letters ARK? Well, one goal of ARKs was to break out of the silos and walled gardens surrounding many identifier systems. So what got built was the name to thing resolver, or N2T. The domain name n2t.net is short, which is helpful in citation strings. Another big benefit of N2T is that it resolves over 900 compact identifier types. So if you forget where the resolver is for ISBN or protein databank or KEBI IDs, or for ORCID, ROR, Handle, DOI, or ARK identifiers, just remember n2t.net. Not only does it track them for you, but it reduces the reliance on individual host names. And its compact identifier support saves precious visual real estate in citations. ARK organizations include a wide variety of memory institutions, nonprofits, for-profits, data centers, and government agencies. A few are listed on this slide. At the lower right is another example ARK identifier, which you can recognize by the signature ARK colon inside it. This one points into the collection of the Louvre Museum. What are ARKs used for? Here are some examples. The biggest ARK user is the Family Search Genealogical Research Organization. Next is the archive of source files for journal content published in the global north. The Internet Archive has been assigning ARKs to scanned books and texts since 2008. The French National Library was an early adopter and has a wonderful image depicting the biblical ark. ARKs are also important for people, especially historical figures. For example, 19th century mathematicians Ada Lovelace and James Maxwell do not have ORCIDs, but they do have ARKs. If you're wondering, ORCIDs are open researcher and contributor IDs, so these ARKs are like ORCIDs for dead people. Finally, there are several projects assigning ARKs to vocabulary terms. Here's an example ARK from the British Library, whose NAN is 81055. Again, those 5 digits represent the NAN, or Name Assigning Authority number. If you're familiar with DOI prefixes, NANs are very similar. 67375, that's the NAN reserved for the French National Institute for Scientific and Technical Information. On the right is one of its 22 million records. Inside the red rectangle, you can see the ARK they assigned along with its NAN. Note how this ARK URL begins with their own resolver, not with N2T. It ends with an opaque string that tells us nothing about what it's assigned to, but we can tell from the metadata in the record that it's assigned to a conceptual thing. This example shows the NAN reserved for the Leventhal Map and Education Center, which partners with allmaps.org in the Netherlands. Inside the red rectangle is the ARK they assigned, along with its NAN. This shows the compact form of an ARK because it has no resolver in front of it, just the globally unique identity. Finally, this is a look at an ARK at the Internet Archive, whose reserved NAN is 13960. On the left is a major library standard that was digitized and deposited in their text archive, and on the right is its metadata record. Inside the red rectangle, you can see the ARK they assigned, its 5-digit NAN as well. Again, this shows a compact form ARK, so there's no resolver in front of it. Compared to the identifier field above it, the ARK is opaque, which helps it to age and travel well for external citation. People find opaque identifiers to be, well, opaque, but fortunately, you can see a bunch of metadata above that. That metadata includes 2 URN identifiers. Having multiple identifiers may not be ideal, but it's common, and it's often good practice to preserve all the identifiers that come in with an object. As durable, non-paywalled web addresses for any kind of object, ARKs protect whatever we invest in creating linked data. Each ARK contains a globally unique identity independent of the domain that is currently serving it. Unlike domain name centralized persistent identifiers, ARKs flexibly support the four main rules of linked data. For example, ARKs are expressible as compact URIs or as full HTTP URIs. So even in the case of a non-resolving ARK, recipients can still learn its origin by reading the name assigning authority at the beginning. Every URL is potentially persistent, whether or not it looks like a PID. Nor does a URL become persistent when you put a label like permalink next to it, or when the identifier starts to look like a PID, such as when ARK colon or DOI.org is added to the identifier string. Identifier syntax is not magic. It is never more than a suggestion that this link may be more stable than the vast majority of URLs that are produced with no thought for preservation. Every PID is aspirational, based on the hopes of its creator, and there are no guarantees. As a result, PIDs break often by the hundreds of thousands, which is normal. Committed preservation providers will repair those links, those that can be repaired. Keeping PIDs persistent often involves the fundamental technique of indirection, stable identifiers that redirect to other identifiers. So this may be a reminder for many of you of this core PID technique of indirect identifiers, which uses the web concept of the HTTP redirect. So first, here's normal direct access. The user clicks on a URL in a web browser, which sends it to the web server appearing at the beginning of that URL, and a page is returned. With indirect access, the first server contacted says it doesn't know where the thing is, but it returns a message saying that this other named server should have more information. Behind the scenes, instantaneously and unknown to the user, the browser restarts the process by contacting the second server. It could be a third server, fourth, fifth, etc. This is web redirection, and it's like forwarding snail mail to a new address. Many of our ordinary web accesses involve long chains of multiple redirects, all taking place quickly and without the user being aware. So all PIDs are very similar in structure. They follow one pattern and have one basic trick, namely the simple web redirection that's been built into every web client and server for 30 years. Near the bottom, you see what ARKs look like, and above it, all the other PID schemes have very similar form. They start with a resolver, then a name assigning authority, and finally, a local name. For example, ORCID and ROAR are newer PID schemes using the same pattern and trick. Of course, identifying people and organizations is something that ARKs have been doing for 20 years. No PID scheme helps with any of the major causes of broken links, so you may ask why use PIDs at all, especially if there's a fee. One reason to use them is so that the recipient of your PID knows that it has a higher chance of resolving than the average URL. Extra services can coexist with resolvers, for example, to check for and report broken links. But no matter what you pay for your identifiers, it is still your responsibility to repair and maintain them. Like any permalink, a PID signals the presence of an aspirational link, but one that can be recognized in the wild when it is separated from any explicit label. Every web server since 1992 can redirect URLs to keep them stable, but only if the original server that the URL is based on still exists. If you think your server's domain name might not persist, you might be able to use a server that itself is aspirationally persistent, so that links can continue to be redirected. That's the second thing PID schemes offer, namely an aspirationally persistent server that might exist longer than your own. Examples are web servers at doi.org or n2t.net or handle.net. If the original server no longer exists, you might still be able to update redirects on that aspirationally persistent server. Of course, any long-standing library or archive or any consortium or professional society could set up their own web server very cheaply. In fact, they do it all the time. and they would just agree to use it for their own PIDs. Either way, this only works if, and it's a big if the content still exists, if someone has the legal right to make it available, and if they are hosting it online. At the end of the day, redirects are an important but small part of keeping links persistent. To review, here's the grumpy old person view of PIDs. Looking at this table, the big block of no answers in the first 4 rows tells us that no PID scheme helps you with all of the major and most of the minor causes of broken links. So why even bother? Well, some of them are free, so there will be more money to spend on the real work of preservation. If you buy into the idea that PIDs actually provide value, here are some details on things they might do for you. By an amazing coincidence, this table is quite flattering to ARCs. The bottom line is always about cost. No organization pays for the right to create ARCs, pearls, or URNs in unlimited numbers. In the real world, or maybe it's just the academic world, PIDs that publishers use play a key role. When tenure and promotion hang in the balance, DOIs are the publisher's solution, and they are seen as a kind of badge of academic legitimacy. Pearls are free and are common in the semantic web. URNs are useful if you're a national library in a nation that subsidizes URNs. They have the unique advantage of having an internet standard behind them, even if it is frequently abused by creators of bogus URNs. Handles are popular in certain European projects and have a nicely underwritten resolver infrastructure, also used by the DOI system, so they can be good if you can afford them. If you only have a couple dozen things to identify in a year, by all means consider going to zenodo.org and assigning their subsidized DOIs. ARCs are similar to DOIs. Both are PIDs for content and metadata, and ARCs are found in many of the places where you find DOIs. In contrast, ARCs come with no fees, no limits on how many you can create, and no metadata requirements. From the beginning, ARCs have been decentralized and can identify any kind of thing, digital, physical, or abstract. Finally, there is no conflict using both ARCs and DOIs together, which is common in museums and libraries. Some people assign ARCs to everything, and for a subset of things that later need DOIs, they can derive them from the existing ARC string. This next use case is for the Smithsonian, whose NAN is 65665. You can see that number at the beginning of each ARC. You can also see the wide range of their object types, biological specimens, paintings, photos, and sculpture. Note the long opaque names they've assigned, which were generated using the UUID software that's pre-installed on nearly every platform. These unique names are long, unfortunately, but they're very easy to generate. Here are some more details of ARC syntax, including subparts and variants. Right now, we will focus on the NAN, or name assigning authority number. The NAN is a 5-digit number. As such, it is opaque, which is good for longevity. But what if you want to know what's behind the opacity? Well, in a browser's address bar, you can try truncating an ARC so that it stops after its NAN, as shown in the yellow highlighting. This is a stub ARC. If you hit enter after this incomplete ARC, it lets you inspect the 67375 NAN, which is from our an earlier case study. I encourage you to take a moment to go ahead and try this. You can also try it with other NANs, or you can try backing off further to a shorter stub, ending with just the ARC colon, which tells you about the ARC scheme. I mentioned that N2T can serve 100 or hundreds of other schemes. For example, try entering the protein data bank identifier shown in the last line. You can also look at truncate that to the PDB acronym to learn about that scheme itself. Here's what part of a record looks like when you ask N2T to tell you what the 46171 NAN is. Um, the record is, what you get back is more complicated, so this is an excerpt of those fields. You get the record for the National Autonomous University of Mexico, as well as when it was registered in 2017. Very importantly, it tells you where the N2T resolver should redirect incoming ARKs so that they get sent to the correct local resolver. All the NAN results that you can see by playing with stub ARKs in the address bar of your browser, they're all pulled from the main NAN registry. This is just a plain text file that you can look at directly in your browser. You can use the QR code if you're interested. Here's another example record for the National Library of France. Just a quick note, the registry file format is in the midst of being changed to a more broadly machine readable format in JSON. So it sacrifices a little bit of the human readability for still human readable, but it's more machine readable. The file that's currently linked to starts with a big lots of textual description, and you have to scroll to see the records in chronological order. To look for organization, you can use the browser find in page function. So the NAN has two main purposes. It's a lookup key for the resolution reference point, and by defining the root of a global namespace, it isolates an organization's autonomy and responsibility for assigning its ARKs. That way, without interfering with anyone else's assignment, an organization can determine its own policies regarding identifier form, uniqueness, and even reuse. Basically, just as for URLs under its domain name, an organization can freely assign ARKs in any way that it wants. Here's a link to the form you can use to request a NAN for your organization. If you want to practice using it, go ahead, just indicate in the final comments that you're filling it out as a training exercise. So I encourage you all to just inspect that, just get a sense of how it's done. Within 48 hours is the target response time to fulfill requests. So I'm not sure if you've heard about opaque identifiers and its pros and cons, but a great deal has been written about opaque identifiers. They age and they travel well, but it's not the complete story. Because they look like random combinations of digits and characters, they have no apparent meaning to any culture in any time period. Of course, there will be exceptions, but this is good because therefore they cannot mislead or give offense, or rather they're less likely to do that. But that virtue can be a flaw when people want a thing's identifier to hint at what the thing is. One approach to soften this inconvenience is to make the ID shorter and therefore a bit more citation friendly. Of course, the downside is that shorter IDs are harder to keep unique. One emerging trend is to use an opaque base identifier with lucid or non-opaque extensions. That can be okay because extensions are more transient than the base thing itself. For example, image thumbnails are regularly upgraded to be higher resolution. This happens every few years to keep up with evolving demand and advances in storage capacity, network, and rendering speeds. But the commitment to the overall thing is very firm, but the commitment to the bit stream delivered under the thumbnail may be less less durable. Back to details of ARK syntax. We talked about the nan that comes right after the ARK label. Moving further right, the special characters slash and dot or period have special reserved meanings in ARK suffixes. So that makes those characters effectively non-opaque. They help the recipient make inferences about one resource containing another or one resource being a variant of another. In any ordinary URL, you could guess at similar interpretations, but in ARK-based URLs, the guesswork is gone. If you use the reserved characters, you are formally declaring that these relationships exist. Here are the 4 linked data rules for publishing structured data on the web according to the inventor of the web. The way I read it is, please name things with URLs that lead to useful information and to the discovery of more such URLs. ARCs are naturally compatible with linked data because they are expressible either as compact URIs or as full HTTP URIs. Even in the case of non-resolving ARC, recipients can still learn its origin by reading the name assigning authority at the beginning. And as PIDs, they help protect our longer-term investment in semantic web and knowledge graph applications. The rule that links should lead to other links is routinely honored in ARC metadata and is always honored implicitly by ARC syntax and its suffix conventions. The slashes represent hierarchy that a client should be able to traverse. Periods represent resource variants that a client can expect to lead to receive default representations. And privileged query parameters, also known as inflections, such as $info, which we'll see later. These can predictably transform any given URI name to a set of additional protocol reasonable requests. So, for example, the simple existence of an ARC with an internal slash implies the existence of another containing object identified by its parent ARC, obtained by truncating the original ARC at the slash. There's a natural parallelism between ARC suffixes and the popular IIIF image API, which is being used in domains that have lots of images, such as medical research, museums, and botanical gardens. If you have images that use the popular IIIF framework, you can create and manage one ARC for the image and just change the suffix to identify millions of subparts and variants. Here's an example from the BNF, or French National Library. In this long IIIF compliant URL, after the opaque base name, you can read the page number F29, the comma-separated coordinates of a rectangular region, the request for full quality, and the JPEG format. So ARCs are very flexible. You can throw them away when something doesn't work out, which is much easier if you've never told anyone about them. If you don't tell anyone about your ARCs, it's as if they never happened. ARC metadata is also uniquely flexible. You can start with none, and you can add anything, such as whatever is defined in schema.org. For example, there are lots of ARCs with DataSite DOI metadata. You could assign an ARC to something that doesn't exist, because in the planning phase, things need identifiers just so we can talk about them. After all, we name our children before they're born sometimes. At the moment of birth, when we've created a thing, there might be no metadata, except perhaps for a redirection target. Later, we can gradually add draft metadata, which might be reviewed and edited by others through phases of pre-release, preprint, postprint, etc. An ARC should lead to the identified thing, to metadata about it, and to a persistence statement. ARC was the first PID to recognize that persistence is not binary, but nuanced. Here's an example. To request ARK metadata, normally you would just append a query string consisting of question mark info. This shows minimal metadata, who, what, when, where. Very unfortunately, this example is currently broken, but I'm told it should be fixed soon. Um, so ARK metadata is very flexible, as I mentioned before, from none to anything. That includes metadata normally associated with DOIs. For example, many ARKs return metadata in the DataSite profile. This is useful for ARKs identifying journal content. Once again, unfortunately, this example is also broken, and the legacy site where it could still be shown has been taken offline for the moment. So I'm hoping that will be fixed soon. The the question mark info ending is an example of an ARK inflection. An inflection is a grammatical device to modify the meaning of a word by making small changes to the end of the original word. One advantage is that you don't have to assign and manage completely separate identifiers both for the object and for its metadata. Instead, just inflect the original ARK. Earlier versions of the ARK spec called for appending simply one or two question marks, but they're a little harder to support. There's something similar called in function called content negotiation. Um, but instead of just editing the URL in your browser location field, you need tools to manipulate protocol headers. There is no conflict using content negotiation and inflections at the same time. The response format is evolving, but it should be human and machine readable. So JSON and YAML formats are fine if you know what those mean. So persistence is not on or off. Um, it is nuanced because ironically, preservation often involves change. Valuable objects tend to be complex human-managed clusters of digital artifacts that curators are forced to change in order to keep up with changing technical policy, security, and legal requirements, as well as user expectations. So we mentioned the example of larger thumbnail images that creep up over time. There's also improved OCR output that's available to modern algorithms. So you can expect OCR files to be replaced. Another example is consider why does a long-term stable release of a Linux operating system from 3 years ago, why does it still receive regular security patches? Um, there are reasons for that that are not necessarily inconsistent with preservation. Maybe to the most serious preservation person who might demand absolutely frozen bit streams, but that's actually quite hard for most places, repositories to afford. Um, Another example, does an article cover page not change when an author's name is misspelled? Authors generally get upset about that, and repositories will comply. One category thought to be impossible to preserve is for rapidly changing files. For example, an ocean sensor file that grows every 6 seconds, or a database that is annotated hundreds of times per day. At a slower pace, it's not too dissimilar from a journal that acquires a new issue every few months. What do we even call how do we allow for latitude in a nuanced persistence statement that allows preservation to occur on what's already been recorded, but allow these things to grow. So ARK has done some work on this, but we don't have time to get into it today. This is a look at the YAMS.net system that is supported by the Metadata Research Center at Drexel University. Note that the NaN here is more than a number. It has extra characters on the end, namely /H1. This kind of extended NaN is known as a shoulder, which is drawing from locksmithing terminology. ARKs are useful for vocabulary terms or concept IDs because any investment in linked data is more protected with permalinks. Concept IDs are good for things like spreadsheet column header names or variable names, controlled values under those names, relationships, pick list values, etc. Thousands of groups, small and large, across the world are inventing vocabulary or modifying existing terms, but they don't have easy ways to share and get feedback on changes. These are ARCs that point into a large substrate of candidate terms and definitions, and it helps groups to share, discuss, and reach consensus quickly on whatever terms that they will take forward into their own ontologies and standards. So we built a crowdsourced metadata dictionary called YAMS. It lets anyone look up terms to reference. You can log in to comment on other people's terms. You can also upvote or downvote terms and watch them so you get notified if they change. This term is labeled vernacular class, which means it can be changed by the owner, but terms labeled canonical class are done changing. There are also deprecated terms, but they too will always be available because historical documents will be available. You can add your own term and immediately walk away with an ARK persistent identifier to reference it. There's no problem creating multiple terms with the same name string. This one has 13 alternates, but each alternate will have a unique ARK concept identifier. You can also add tags to terms and import terms in bulk via a CSV file. Here's an example of reputation-based voting from Stack Overflow. Here are the controls to use reputation-based voting in order to resist gaming and help developers choose the technical solution that works best for them. In YAMS, it helps users choose the term that works best for them. So finally, for those of you craving a philosophy slide, here you go. Let's consider what a persistent identifier string can tell us, here represented by these 26 characters. Is it data? Is it an identifier? Is it an opaque identifier? We don't know much by looking at it, but it's useful if someone associates it with something. An identifier is really an opinion. It depends on who you ask. In other words, on which name authority you ask. If it is an identifier, it would be terribly helpful if it were inside a URL, such as this one. That's because the domain name early in every URL is actually a name authority. And the HTTPS out in front means we can query the authority implied by that domain using a web browser. When we do that, what comes back is a web page explaining that the string is an example identifier. What we won't see is that behind the scenes, the browser received a 404 not found error. So this modified string looks like a URL, but even though the browser displays a page, according to the official query status, it is not an identifier. Maybe someone else has an opinion. Let's change to a different authority, in this case, the doi.org domain. This third string looks like a proper PID. In fact, it's a DOI, right? Well, no. When we click on it, we see a web page that tells us a 404 not found error occurred. The DOI system has no knowledge of it, and so even though it looks like a PID, it's not a valid identifier. Okay, so let's try again, but using a different sub-authority within the doi.org domain. This time, a browser returns a web page with no 404 error. So we now have a true, valid DOI. So this should identify trustworthy, citable, scholarly content, right? Wrong. In fact, it identifies a kids movie. That's because it was created by a registration agency that assigns a DOI to every movie made in the United States. The point is that you can assume very little about an object or its persistence by looking at its so-called persistent identifier. If it looks like a PID, that is only a suggestion. What you get back also depends on when you ask. The query experiences described for this slide were made in early 2024. Persistence is not conferred by a string, prefix, or syntax. That's true whether you're dealing with ARKs, DOIs, handles, URNs, or any URL-based permalinks. Tools for implementing ARKs can be found in the resources area of the ARK Alliance website. They include minters for generating unique opaque strings, includes documentation. There's the old Noid software written in Perl and a Dockerized version of it. There's also a very nice combined minting, binding, resolving solution, which was begun by the Internet Archive and was extended considerably by the Frick collection. That's called ARKlet Frick, and that's quite promising. For pure minting solutions, you can use any simple counter or the very common UUID software, or the less common but shorter ULID software. There's also a very full-featured ARK plugin, which is a minter and resolver if you're a publisher using the Open Journal system. And the University of Toronto Scarborough has an in-house library system for ARKs that they're making available open source. If you're implementing ARKs, you may wish to consider using the suffix pass-through used by N2T and EasyID. It's also been implemented by the ARKlet Frick software. The way that works, it's a feature, suffix pass-through is a feature that a web server can choose to support in order to greatly increase the number of identifiers that it can forward. It dramatically reduces the burden of maintaining identifiers by permitting one identifier to stand in for millions. The way it works, given a URL for the stored identifier, if an ARK arrives with an appended suffix, N2T will reappend it, pass it through to the destination during resolution. This is critical for IIIF applications so that the many addressable subparts and formats don't all have to be separately registered, maintained, and possibly paid for. That is, in fact, an important limitation of the handle system and therefore of the DOI system. This idea for suffix pass-through is pretty much identical to the Perl.org concept of the partial redirect. This final case study uses a visualization from Dave Viglace and the U.S. National Science Foundation iSamples project. It allows us to visit the South Pacific island of Moorea in French Polynesia. Each of the colored points represents a physical sample, and the towers indicate that many samples were collected at the same location. Each sample point has an ARK identifier, which is displayed when mousing over it. Clicking on one of the points brings up summary metadata, which allows you to link back to the original collection. Following that link to the Smithsonian, you can find more details about the specimen with cross-references to analyses, publications, and other material. The interlinking is done with millions of ARKs, and the open source software can scale to accommodate hundreds of additional collections. Currently, the iSamples system assigns identifiers to biological specimens, rocks, and archaeological artifacts. So, in conclusion, what do 11 national libraries, 185 universities, 209 archives, 104 museums, and 101 journals all have in common? They are all registered to use ARKs. They are open, mainstream, non-paywalled, persistent identifiers that you can start creating in under 48 hours. The ARK Alliance was formed in 2018 to sustain the ARK infrastructure, and we welcome input and volunteers for our working groups. I'm also happy to remind people that we had a recent creation of a brand new ARK email forum for speakers of Spanish and Portuguese. So thank you. If there's questions, I'd be happy to take them. I haven't been tracking the chat, so if you want to go ahead and into that.
Hi, John. We have one question so far in the chat, and it said, can you talk briefly about the organization behind ARK and how it can sustain ARK over time if it hasn't already been discussed?
It hasn't been discussed. We're in very actively working on sustainability right now. We're in discussion with, we have some consultants that have been helping us to try to understand, first of all, how to sustain what it is we want to sustain, what it is, what's the value proposition, how we do it without charging fees, without going back on our word about uh, you will never be charged, you'll never have to pay for the right to assign ARCs, but some sort of revenue has to be identified. How do we do that without breaking our word to the ARC community? Um, Another question is, how do we become a preservation organization that doesn't go the way of all of the preceding organizations, which where nonprofits seem to start up and within 6 to 8 years they fold. They fold because something, what did they do that wrong that we can avoid? And that's a very tricky question. We would love some help thinking that through. We just don't want to get in the line and form a nonprofit that is then um, spends all this time worrying about its revenue and keeping its existing staff employed and paid, and then folding because under the weight of the sort of the way that can take over your life. So I'm saying that pretty poorly, but we could use some help with that.
Okay, we had some comments and another question. One of the comments was fascinating presentation, John. Thank you. They're looking into working groups. There was a silly idea. It'd be fun to have a DuckDuckGo and or KAGI, I don't know how that's pronounced, bang command to easily resolve an ARC with into T in your browser. And then there was a question. If it
Okay,
is
well, let me,
possible,
I,
comment on those. Go ahead.
yeah, it would be great to have, essentially, it's been the dream of every persistent identifier scheme to be recognized by the browsers and unfortunately, the browser makers never really took that seriously. Probably the closest they came was with the URN, recognizing it as a URI scheme, but the, there's no there's no resolver for the URN. There's no known resolver. So I agree. It would be great if you could do it within the resolver and with minimal fuss, like less fuss than installing a plugin. Of course, that the whole plugin landscape may have changed since I last looked at it. So I'd be happy to explore that and talk about it more if there's easy way to do that. Sorry, Ronnie, go ahead with the next
No,
one.
never apologize to me on that one. Someone asked if you will be uploading your slides into
Yeah,
schedule. And
yeah.
then is it possible to have an ARC without any metadata? How can what the ARC identifies be known?
Well, you could say that there's the question of there's the arc between you and yourself. You may know exactly what it stands for, but generally, especially if they're opaque, you'll need some sort of note for yourself. So there's a question of like, who do you tell about it? Um, so the very usually the if the very first bit of metadata that an ARC has is the URL that it redirects to. So you may not know anything about it except, well, it redirects here, so that's probably what this ARC is about, is that thing. So you could say that an ARC without a redirection target is almost useless. I'll tend to agree with that, except if it has some personal meaning to the creator. ARC with the redirection target, that gets you kind of the typical experience of any URL shortener or Perl.org. A lot of Perl.org links, wordlessly get you to a place. So that's something, and often that satisfies a number of people. But um, properly speaking, I mentioned that identifiers and metadata really go hand in hand. When a thing's not available or it's temporarily not available, to have some knowledge of what it's been bound to in the past, basically, effectively, metadata is super important for identifiers as is one of the pillars of identification. I'll stop there.
And we have one more comment. They said it was great to learn about this. Thank you. I'm going back
Okay.
to see,
Um,
make sure I didn't miss any and check. If you have any more, we still have time. You can go ahead and put them in or any other comments.
I really appreciate the chance to talk to your folks and the questions that are coming up. Um, the infrastructure, as I'll mention, is a little bit is still in flux. The California Digital Library has been doing a technology refresh, and there's always a little dust that settles, still has to settle with the latest refresh. And we're modernizing the way that NANs are assigned, and the, uh, the code, the software base got a lot simpler. So, and it's written in Python instead of Perl, so that attracts many more developers. But we're quite interested in new working group volunteers. We're an all-volunteer organization at the moment. We're working hard to become a legal entity, so we can have a bank account and own a domain name. Wouldn't that be nice? Um, Help on all fronts would be very welcome.
What advice do you offer to individuals that are kind of new to this kind of work? Like how to get started, what resources to kind of look at?
Well, that resources page is a good starting point. Another one is you can request a NAN for your organization while you're still making plans. A lot of people ask it for a name assigning authority number when they're just getting started, so they don't yet have a resolver. So it's something you can sort of figure out. Extremely um, there are some extremely easy ways to get online. If you have, for example, if you are um, really depends on the application. So OJS, the Open Journal System. If you're already using that software, there's a nice plugin that you can just configure it and you get a NAN. You configure your plugin and you're off to the races. You're already using them. If you're using, there's a couple of sites that are basically WordPress sites, um, and you can do some things very informally and manually. Basically, your local resolver is just your local web server. And the main trick is to here comes here comes an incoming URL to your local web server, but it looks like an ARK, so it has to be on the way in. It has to be transformed into one of your URL paths. And so typically, unfortunately, that needs either a little bit of technical staff or it needs a platform that's already has a solution available for you. So, often it's one technical person can get you there. Sometimes I'll mention Project Gutenberg. That's they have some of the most persistent identifiers in the entire digital library field, or that they've been doing, they've using the same identifiers from before the internet was created. And they had an Apache web server and basically two lines of rewrite rules, two-line configuration change allowed them to take ARK identifiers coming in and map them to their existing identifiers. So that was for them a trivial change, but they also have technical expertise, a homegrown system that's was easy to modify. So unfortunately, the answer will change a bit depending on your situation. And what we could use actually is we could use better documentation that sort of says, if you're using this platform, here's a recipe, and if you're using that platform, here's a recipe. We need to collect some recipes for bringing people online easily.
Oh, that would be nice. That was awesome. Does anybody else have any questions? Last call. I feel like a bartender right now. Last call. Well, this was great. I appreciate you sharing this. I love, like, I'm not into anything linked data. I'm not sure how I ended up helping with this conference. It's my third year helping with it. But I love coming and learning about it. So I love that you shared this. It's great. And
Well,
I
thank you
really
for the chance. Appreciate it.
I'm looking forward to great things coming from this. We will be having another session. It'll be starting at um, I forgot, I'm an hour behind. It'll be starting in about 15 minutes. If you guys want to grab another coffee or Coke or tea, whatever you need, a break, bathroom break, it will be back in this session, unless you're going to a different workshop. If you do have questions, go ahead and keep posting them and we can get them to John. Um, and otherwise, we'll see you guys in just a little bit. Thank you.
Okay.
How does that look?
Hey, Darnell, are you able to share?
Yes, I just did, I thought. Do you see my screen?
I see it on the presenter. I'm not seeing. Oh, wait. Yep, I see it.
Okay.
I have my thing full screen, so all I can see is my thing in front of the presenter thing.
Okay.
And
Uh,
your sound sounds good. And you have a co-presenter, right?
yeah, Corey Lampert. She was in this last session. She might have exited out. I'm not sure if she's in here still. Yeah, she's
Okay.
not in here yet, but she'll be in shortly.
I just wanted to test her audio when they get in here. You sound perfect, by the way.
Thanks. And then just a quick check. If I flip these tabs, did you see my screen shift?
Yeah, it's
All right.
on 2025 LD conference.
Yep.
Mhm.
Perfect. All right. Well, I think I'm ready to go. I'm gonna go run to the restroom, so I'll be back at the top of the hour. Oh, I did have a question. On the scheduler, it said it was an hour session. I thought this was supposed to be a 75-minute session.
It is an hour, and then you have 15 minutes for questions at the end.
Got you. Perfect.
Yeah.
All righty then. Well, I'll off to the restroom. I will be back shortly.
Hi.
Thanks.
Afternoon, everyone. We're going to get started in just a few minutes. Corey, have you made it in the room yet?
Yes, I have. I'm here.
Okay, I just want to check your audio. It's good. Okay, guys, we're going to get started. I'm Ronnie Cox. I'm your moderator for this session, and Mary Edcock is our co-moderator. And today's session is going to be brought to you by Darnell and Corey. Darnell is a special collections and archives metadata librarian and associate professor at the University of Nevada, Las Vegas. As the lead metadata and semantic web strategist, he oversees Wikidata-driven metadata initiatives, large-scale remediation projects, and metadata workflows and documentation. He co-authored linked data for the Perplexed Librarian. Sounds like I might need to read that one. And conducts research on metadata and resources discovery in digital libraries, ethical representations, and public knowledge graphs, and data integrations. His work focuses on linked data implementations, graph-based visualization tools, metadata reconciliation services, workflow optimization, and systems interoperability. He holds an MLIS from San Jose State University, specializing in information organization, description, and analysis, and retrieval. Corey Lampert is the head of digital collections in the Special Collections and Archives Division of UNLV University Library. She is responsible for leading the library team responsible for digitalization of cultural heritage materials, metadata creation for discovery and linked data creation, and the administration of the library's open source repository of digital special collection materials. She has been a co-PI on the National Digital Newspapers 2014 to 2020 grant to digitalize historical newspapers from every county in Nevada, and she is the co-author of the book Linked Data for the Perplexed Librarian, ALA editions. She serves in leadership roles in the International Federation of Library Association and the City of Las Vegas Open Data Initiative. She is also interested in mentoring and supporting of early career information professionals. The floor is yours.
Thanks very much. I'm going to kick it off here, and I believe Darnell will be running the slides. Um, Thank you so much for joining us today. We're really excited to be here. Today's session is going to begin with some background on the collection that grew into the linked data project that we're going to discuss. So Darnell, you can advance to slide 2. It all started in 2014 with a grant that we had to identify and digitize collections documenting the African American experience in Las Vegas. So during the last month of that grant project, we received a portion of the Clinton Wright photograph collection, which documented Las Vegas's historic West Side. Unfortunately, because it was the last month of the grant, there was no time to do a lengthy digitization project. And the only access we were able to provide to the collection at that time was through contact sheets with titles of the shoot from the photographer. Because this was not the approach we ideally would have taken, we always intended to go back and do more. The west side of Las Vegas is a historically African American neighborhood, and it's shaped by some of Las Vegas's most important civic leaders, such as Dr. Charles West. Dr. West was a major figure in this community's history, and he ran the Las Vegas Voice newspaper. And by the year 2020, UNLV had come a long way from the first grant. We had hired archivists to create standards compliant finding aids. We'd done a public exhibit on the Black community in Las Vegas. And we had new high quality digitization equipment in our lab that could handle film materials. So when we completed the digitization of the Las Vegas Voice newspaper back in 2022, it was time to go back and prioritize better access to the Clinton Wright photograph collection. No other archive in Las Vegas does a better job in capturing the community's lived experience through this visual documentation. So today we're going to do a walkthrough of our project, including lots of technical details. But first, I would like to introduce a key component of this work, the student labor that's driving much of the innovation on this project. Next slide. The original plan for the Clinton Wright photograph collection was to write another grant and hire a project manager and metadata specialist to enhance the metadata. But when that grant was not funded, we needed to shift gears. And instead, we decided to work with resources we already had access to, 5 student assistant positions that work roughly 12 hours per week in our department. These students are mostly undergrads and they do digital capture and metadata work. And while some might feel this is beyond what can or should be taught and managed in the student environment, we at UNLV have had great success in working with a team of students over multiple years. The students have been responsible for the digitization of complex film collections and the creation of high quality metadata. In fact, students have enhanced our workflows through feedback and suggestions. And in the case of metadata, they are adding significant value to the collection by researching and expressing relationships that they're finding in the data. Students have also taken these skills and done scholarly presentations, open house demonstrations, and news appearances as sort of our undergrad experts on the project. And this has also been really meaningful for them. Now I'm going to pass it over to Darnell to give us an introduction to the linked data approach to this.
Thanks, Corey. So I just wanted to give you guys a little background and some origin story facts about this project. And it was really interesting. The information kind of grew organically as we dug into these collections, starting with the Clinton Wright photographs. But as we started working and finding and digging into this collection, we started to learn a lot about some key figures and just some key players in the community started to emerge as we started to do this work. So I want to give you a little background. And really, all of this work really starts and is centered around Dr. Charles West. Let me give you a little background about him. Charles I. West was born in Washington, D.C. in 1908, and he earned his medical degree from Howard University in 1933. After completing his medical training in Kansas City, Missouri, and Tulsa, Oklahoma, he served as a field surgeon during World War II, where he was wounded in France. Following his military service, he studied at the He further studied at the London Tropical School of Medicine before returning to the United States. In 1954, Dr. West made history as the first licensed Black medical doctor in Las Vegas, but his impact extended far beyond medicine. He quietly, behind the scenes, advanced civil rights efforts in Las Vegas. And most importantly, he founded the Las Vegas Voice, the state's first Black-owned newspaper, which served as a powerful voice for the West Side Las Vegas community. Also, a key to mention was his wife, Dottie West, who was a dancer, singer, and businesswoman. She also was the mother of John P. West, who also served as the newspaper's editor. And she also worked as the editorial consultant for the paper. John P. West was a heavyweight in his own right. He was the managing editor of the paper, but before he died, he had a great career as a psychologist. He served as the managing psychologist for all Southern Nevada prisons within the Nevada Department of Prisons before he retired. And then you have Clinton Wright, of course, the photographer whose collection was really central for this project. So the slides really illustrated how key entities are connected through RDF. So as you can see here, if you're not familiar with linked data, this is a syntax called Turtle. And it's a really easy way to teach as well as to write linked data. It's one of the standard syntaxes that is being used to write linked data, and I actually prefer to teach with it because some find working with RDF XML a little bit hard, and same thing with some of the other serializations. But as you can see from here, you can see these connections start to merge. With Charles West, he's a civil rights activist. You can see he was the founder of the Las Vegas Voice. He's linked to his wife, Dottie West, and their son, who served as the managing editor of the paper. And as you can see in the data, they're connected through a property called Agrelon has spouse and Agrelon has child. All three, Charles, Dottie, and John, are connected to the Las Vegas Voice through employment or founding roles using properties like has employer, founder, has employee. And then we also model Clinton Wright, the photographer employed by the paper. His collection, the Clinton Wright Photographs, is linked to him as the creator and West Las Vegas, the community it documents. West Las Vegas itself is modeled as an administrative area, giving spatial context to the people and organizations in this network. This snapshot shows how people, places, organizations, and collections come together through simple RDF statements to tell a connected community story. So workflows, moving from digitization to metadata creation to knowledge graph. We begin with digitization, the process of converting physical photograph negatives into digital surrogates. This step not only preserves delicate historical materials, but also sets the stage for broader access and reuse. In this project, digitization opens the doors to deeper engagement. Corey, you're muted.
Sorry about that. Every digitization project at UNLV gets a detailed plan, and the plan comprehensively documents decisions about the collection's transformation into a digital project. The plan usually includes rights information, a review for sensitive or restricted materials, an inventory of formats and materials, assignment of appropriate digitization equipment and specifications, and a plan for metadata enhancement from whatever exists in the finding aid. So this project was a large project, and it had over 8,000 negatives in 3 primary formats with an assorted additional miscellaneous set of formats stored in additional folders. Digitization of reflective materials is a more difficult task than capturing paper or text collections or just flat printed material. And there was a significant learning curve for the students. Using the phase 1 camera and the film kit we have in our digitization lab, students worked over about 2 years successfully digitizing the items. Next slide, please. So after the plan that I mentioned was created, students were brought into the workflow. And as previously mentioned, students are trained to capture according to procedures for the camera and to the national specifications or international specifications. They also use procedures that we've created to follow a file naming convention, and they go through significant training to understand the digitization plan and how to capture the materials. After they capture, the students review their work as a team and with their supervisor, and they check things like image quality, orientation, cropping, file structure. Due to the subjective nature of film digitization, training was a bit longer than normal, and at times we had to recapture images that were not in focus or at the right specifications. But through the process, we did work to document the progress of the project in a database called Airtable. And as we QC things, batches were then forwarded to a library staff member to ingest into our repository. We do use provisional metadata that comes from our archive space platform as a starting point for metadata. But before we talk in detail about the metadata work the students undertook, let's take a moment to step back and understand the overall metadata and linked data strategy developed by Darnell in his role as the strategist for digital collections metadata.
So, data modeling. With digital assets in place, the next step is to determine how we represent information they contain. Through data modeling, we identify entities and define the structure for describing them using ontologies. This diagram illustrates key modeling decisions when connecting a UNLV node, represented in red, to external authority sources via semantic relationships. The UNL entity links to Library of Congress subject headings, or LCSH, using the schema has occupation property. We link to the library name authority file, or LCNAF, using a SCOS exact match. Geonames using either birth place or death place. And then we can also link to Wikidata using a SCOS close match. These connections reflect deliberate choices in how entities are aligned across vocabularies to support richer discovery and contextualization within the knowledge graph. Here, we're looking at how we modeled organizations using schema organizations as its base class. Depending on the type, like if it's a school or a business, we could use more specific subclasses. Each organization in our local UNL namespace is also connected to external authorities, including, again, Library of Congress's name authority file, GeoNames, and Wikidata. This lets us retain local control while aligning with broader linked data standards for interoperability and discoverability. And I want to just make this note. This framework is really designed to be very flexible. We don't have to use the Library of Congress's name authority file or Wikidata. You can use any name authority file you would like. We just happen to use that as because we are a NACO contributor and we want to make as many links as possible. Now this slide focuses on how we establish relationships between entities, what we call connecting node to node. Using properties from schema.org and Agrelon, we link individuals to organizations or other people. Agrelon, if you've never heard of it, stands for Agent Relationship Ontology, and it's managed by the German National Library. Um, these relationships, whether professional, familial, social, are key to surfacing the interconnectedness of community life. And by making these connections explicit in RDF, we move beyond isolated data points and begin to model real-world context and meaning. So, once the data model is in place, it's time to put it into action. Student researchers engage with materials, describe, annotate, and enrich the collections while working closely with myself, who manages new authority records to ensure consistency and quality.
So once the high-level decisions are complete that Darnell has talked about, students are assigned batches of defined digital objects. And the students receive training from Darnell and their student supervisor. And we're not talking just about training presentations or one-offs. They are also provided with written documentation, a listserv where they can share metadata questions, and they are engaged in standing metadata meetings to share their questions and experiences with us and with each other. Metadata creation does speed up after this training, but there's always a subjective component to it. This is the cataloger's judgment. And because of that, communication, collaboration, and documentation of decisions amongst the metadata creators is really essential to the metadata quality. Along the way, as students are creating metadata, we want them to take this vital knowledge of the people and places in the photo collection that they've researched and capture things they have learned. They gain a lot of details and examples that can be used in the collection by looking in the Las Vegas Voice newspaper or in other research sources. So we challenged the students to come up with a central place where they could all look at and access each other's research. And as students do, they impressed us. They came up with an Airtable base, which is a database where they're keeping thumbnail images, notes, and links. And this has been a really important tool in enhancing entities. Darnell's going to talk now about the entity enhancement process and how that leads into metadata creation.
The metadata process begins with identifying a distinct entity, such as a person, place, or concept that needs description. The metadata creators gather relevant contextual information to enrich this entity's profile. Next, the metadata manager, like myself, creates the agent record in archive space, our archival management system, and that ensures consistent documentation. This agent record is then synced to our Special Collections and Archives portal, where it becomes part of a linked data knowledge graph, enabling enhanced discoverability. Once the entity is in the portal, its metadata is further enhanced with additional attributes, roles, and contextual details to improve discoverability. Semantic relationships between entities, such as affiliations and collaborations, are formally encoded, strengthening the overall graph structure. Metadata creators are notified when the entity is available for use. And finally, they link digital objects like images and documents to the entity, providing rich contextual access to related content. With metadata in place, we shift focus to linking, storing, and surfacing the data. This phase sets up the infrastructure that lets our work function as a knowledge graph, ready for connection, exploration, and reuse. The knowledge graph workflow begins with step one, where the triple store is configured. This enables the foundational environment for storing and querying RDF data using Sparkle. Step 2 involves loading multiple ontology RDF files into the triple store. These vocabularies define the structure of the graph and provides the terms needed to describe entities and their relationships. Step 3, the metadata manager, like myself, selects appropriate classes and properties from the established ontologies. This ensures that the data is semantically consistent and interoperable with broader linked data standards. And then finally, in step 4, RDF data is written into the triple store using a Sparkle insert statement and the turtle syntax. This format allows for clean, readable encoding of triples, making the data easier to manage and to debug as the graph evolves. So as you can see, the first step is, where we're going to configure our triple store, essentially setting up the environment that will store the data and reason over our data. We begin by creating a new repository, assigning it a descriptive name and purpose that reflects the scope of our project. This helps with management and discoverability as the work grows. For reasoning, we selected RDFS plus optimized rule set. This choice allows for lightweight inferencing, such as recognizing subclass relationships and property hierarchies without overburdening performances. This balances the idea for an evolving community-driven data like ours. Once the repository is configured, the next step is to declare the namespaces. That's the shorthand prefixes that links our data to external vocabularies and ontologies. This not only improves the readability of the RDF triple and Sparkle queries, but it also ensures consistency when referencing shared terms. By clearly defining these at the outset, we ensure that our data is both human readable and semantically inoperable. Now we get into loading ontology RDF file. This project draws on a mix of well-established semantic web standards and domain-specific vocabularies to express relationships, define classes, and ensure interoperability. We use schema.org to define common types like people, organization, and places, SCOS to model concepts drawn from community knowledge, Agrelon to express the nuanced relationships between people and organizations, GeoNames ontology to add geographic context, RDF, RDFS, and OWL properties and classes to formally structure the data and define relationships. And then we use the XSD or the XML schema data type to standardize values like date strings and our string literals. Together, these schemas and ontologies provides the backbone of our linked data model, allowing for flexible reuse and alignment with other data sources. To model the diverse entities represented in the historic West Side, we applied a wide range of schema classes. These included people, civic structures, businesses, schools, organizations, and cultural venues, reflecting the community's complexity and vibrancy. Grouped by type, they helped us organize and interlink data in meaningful, queryable ways. As the project continues to grow, new classes and relationships will naturally emerge, deepening our ability to represent the community's story through linked data. And then in the final step, we load our structured RDF data into the triple store using a Sparkle insert query. I'm sure most of you familiar with Sparkle have used Sparkle select, Sparkle ask, and maybe even Sparkle construction to create data, but this is a way we would insert data into the triple store. So this example represents a rich entity description of Charles West. You'll notice we bring together multiple vocabularies, schema.org for the core descriptive properties like name, birth, and death details, education, affiliation, SCOS for concepts labeling and linking to authority sources, Agrelon to model social and professional relationships, and of course the UNL namespace for our local, representing our local taxonomy terms. These triples bring together biographical metadata, contextual relationships, and external references to form a well-connected, semantically rich resource. Once inserted, the data becomes queryable, linkable, and is part of the broader knowledge graph. This step bridges structured metadata and the querying power of the semantic web. So it's 12:10. All right. So this is really ends like our presentation for this section. Now we're going to move into the hands-on activity portion of this section. We shared the website. We have a supplemental website. Let me copy it again and give it to you one more time if you haven't.
I just put it in the chat.
Thank you very much. So if you guys want to follow along, we could go there. Go here. So you go there, I'll bring you to this website. It'll have general information about the project, some of our modeling decisions we've discussed, list of our class and properties used. We're going to go to the hands-on section. So let's start with activity 1. So I would like to take some time for you guys to actually work independently. Go ahead and look at this photo. And this photo is from the Marie and James B. McMillan photograph collection. James B. McMillan, he was the first licensed dentist, Black African-American dentist in the state of Nevada. And he was actually one of Dr. West's, one of his closest homies. So who can you identify in this photograph?
Sammy Davis, obviously.
Definitely, definitely. And for those who didn't know, this is a young picture of him to the far left. From left to right, you can see I have a show caption button, which will then reveal the caption. And so as you can see transcribed from the back of this image, the Sands Hotel before 1962, left to right, Dr. James B. McMillan, Dr. Charles I. West, Sammy Davis Jr., and then Monsignor James B. Impey, who was the pastor of St. Joan of Arc's Catholic Church here in Las Vegas. And they presented him, Sammy Davis Jr. an Award of Merit honorary fellowship to the Sammy Davis Jr. and the Will Maston trio from the George Washington Carver Memorial Institute for outstanding contributions to the arts, humanities, and race relations. Also, to let you know, Sammy Davis Jr. was a childhood actor who was also a childhood entertainer who was also a member of that group. So if you could go down, and then I would like you guys, I'm gonna give you guys maybe 3-4 minutes to work through the part B section. And you can see we have a code box. And so you can actually replace and start typing RDF in this file. And so we'll be using through these exercises, these code boxes for you to practice typing RDF using a turtle syntax. So if you go ahead and participate in the part B, go ahead, I'll give you a few minutes to click through and the try. And then when you guys are done with that, just go ahead and just give me a thumbs up.
Darnell, For
Yes,
us that have never done this before, can you put in 1 for us? Because I
sure.
know there's probably someone sitting there looking at this going, I have no idea what to do.
Sure. And if you scroll down, I'm maybe getting a little ahead of yourself. So right here, what we're defining. So I'll just go ahead and explain this right now. Um, this box right here, we have our namespace declarations right here. This is actually in the Turtle syntax. But since Sparkle 1.1, when we write Turtle, you could either write your namespace declarations in this syntax or the Sparkle, which is usually all caps, and then there's no periods after the URIs. For this one, using this class, A is shorthand for saying RDF type. So we're basically, if you've worked with Wikidata, this is the P31 property or the instance of property equivalent. And so what I've asked you to do is replace this with the appropriate class. And as you can see from my example above in part B, the St. Joan of Arc's Catholic Church is classed as a schema organization. And so what I would do is just replace this with schema : organization. And then you can see the next line. This entity also has a label, an English label with St. Joan of Arc's Catholic Church. And so that triple is complete. Now, if you guys already were successful to do that, there was a bonus challenge here where if you could find a Wikidata QID for it, and from what I've told you on how we model it, you would be able to go ahead and add that. So what I would do is just copy it, go to Wikidata, there it is. St. Joan of Arc's Catholic Church. We got that Q number. So, oops. So what we could do is just continue this and then say SCOS : close match. And then in the URL, Q, and it would be WD : Q number. And so right there, that's how we would have added the URI to it and stuff. And you can see up there, I've already had the WD namespace already put there ready to go and stuff. And if you append that Q number to that namespace, it would resolve to the entity in Wikidata. And you would be able to do the same thing if it was a Library of Congress record. We would use exact match, and we would then use the name authority file URI. So then it would be in a square, it'll be in brackets or like in between, like greater than, less than. All right, let's move on to the second activity. Take some time and just read through this activity. Understanding how to express structured metadata in RDF is key to building your knowledge graph. Below is an example using real entities. So you can see here goes a full turtle file with the concept. You can see the concept UNL 16527 is a SCOS concept. And then you go on the next line, it's a person. And then you see we use a SCOS pref label, West, comma, space, Charles I. This is Dr. West. You can see his note. I've declared that he is in scheme. So there are two ways. This question actually came up in another session earlier today. So there are two ways to do this. Some people want to mess with quads and you get into the, name graphs and stuff. But before Sparkle 1.1 was updated, Sparkle protocol was updated, to basically separate your stuff in various collections, you would either use SCOS in scheme or you would use RDFS is defined by. We could use a name graph, but for teaching purposes and for this project, it just will just make you have to write some more lines of Sparkle code to federate the different name graphs together and stuff. And I don't really think that's necessary and stuff. So you can see all the stuff we've done. And then this example uses schema.org, SCOS, and Agrelon vocabularies again. And then we have a breakdown of the actual triples on what it's doing. So we're in part B, we're gonna be building on what you've learned in the first activity. We're gonna build on classes from the activity 1. So for this second part, I want you, using the example URIs and the classes below, I want you to write RDF statements for each entity. And for each one, use the A keyword to assign the appropriate schema class as its RDFS type, right? RDF type. I want you to add the SCOS preferred label, and then I want you to add a note so you could describe what this entity is. And so I've given you 1, 2, 3, 4, 5 examples. And really, it should only be a couple lines, and I'll do the first one for you. So we already named the UNL namespace, so I'm not going to use the full URI. I'm going to just say UNL colon 3454 is a schema person. Oops, it's supposed to be comma, colon. Oops. So the next thing I would say is this entity 3454 has a SCOS pref label space double quote Davis, Sammy, Junior. We'll just do something like that. I will always type it after your double quotes at Ian, because this is the English label. SCOS note. Or another thing you could do is just borrow from the wherever this URI came from, which I'm gonna do right now. And I'll just use that first sentence there. Oops. And then most importantly, I want to make sure that and tell it is in this namespace. So that is the basic, any kind of data mining or data thing, entity extraction is the first step. And so I try to always, by nature, you first define the entity, then you want to class it or subclass it. You got to give it a label because technically the name is not Sammy Davis Jr. The name is UNL colon 3454 that has an English label, right? And then we have the note, and then we're telling it it's in this scheme and stuff. So this is our turn. And then if I wanted to, I could go grab the NACO record, link it, go grab the wiki data. He has a Wikipedia article page, so that means there's an entity in DBpedia as well. So you can link it that way. or in any other name authority file you would want to use, you could go ahead and add that. So just continue on for this. This is some more entities. This is adding properties. Like if I wanted to add his birth date, this is a new one for you guys. So with the birth date, it would be, I'll just put 1925, but instead of typing it with an English label, we will use caret XSD date. Now we know that it's a date. If there were other numbers in there, we could use it with the XSD schema. There's, non-negative integers. There's like, you type it however you needed your string to be typed.
Darnell, do you want to pause and take questions from the first two?
Sure. I do not see I can't see
Okay.
the window, but
I'll read them to you. First, there's a question about, as a NACO contributor, if the NAR didn't exist for an entity in the project, would you or one of your colleagues in the library then make the NAR so that the SCO's exact match relationship could exist?
so it really just depends. Not everything in our local vocabulary warrants, or we have enough information to establish it according to the NACO standard. So it really just depends. Now, when it came to my NACO contributions, my workflow is I would create the wiki data at the same time that I'm creating the NACO. And so I would incorporate the NACO URI into the wiki data and vice versa, the wiki data URI into the NACO record.
Okay, great. Let me move to the next question. What platform are you using for your local RDF triple store?
Yeah, for me, I'm using GraphDB. And I really liked it. I spent last year comparing all these different triple store, basically independent. When the Wikimedia Foundation would hire the graph consultant to look over triple stores for the move of, out of Blaze Graph. I too, because we've been looking, we currently don't have a public endpoint for our portal link data, but this project is a different beast. The intention for this is to build web applications and semantic web search sites based off this social graph. So it serves a little different kind of purpose than the stuff in our digital portal, which is connected to works and stuff like that. This is more so with this project, we're documenting a social graph, not necessarily an agent connected to a series of works.
Okay, let me move to a question about one of the entities. This is about St. Joan of Arc Catholic Church. Would schema Catholic Church be an appropriate top level type, or less so since that is a subtype of the schema place?
I'm glad you asked that because that's really a modeling decision thing, right? Like, are we talking about the place, or are we talking about like a corporate entity, right? So you really have to like wrap your head around it. What are we describing it? And so I intentionally made it an organization because there are constraints on the kinds of properties used. So if I originally, when I was going through the model, I originally was like, oh, schema has a Catholic Church, class. Perfect. And so when you go there and you go look up the actual properties there and the constraints within it, then you realize, well, that's not really what I'm talking about. I'm talking about the organization, not a location. And that's why in this example, I'm modeling it as the corporate entity, not as a location, because we could model it as a place. And according to the model, Schema Catholic Church or Schema Church, it's a building. They don't, it's not the organization, it's a building, it's a location.
So following along with that, Darnell, there's a Wikidata Q number for the Catholic Church that says it's an instance of a building, not an organization. Does close match reconcile that discrepancy?
And this is why we use close match instead of an exact match, is because sometimes we may come across an entity that is what we're talking about, but the constraints in there don't line up with I'll just say the reality of the data model itself. Like when we talk to computers, they're very literal, and this stuff really means things to us. Whereas we could just in our conversational speech, we can infer that information. Oh, Darnell's talking about the church or the congregation versus the building, so it's really working with machines and working with machine code, it's very literal. And so those kinds of issues will you have to think about that and see how that impacts your data modeling and stuff. Any other questions? I want to give a quick Sparkle example before we run out of some time.
Yeah, go ahead. I will keep an eye on the chat.
Thank you. So with any time working with any knowledge graph, whether it's Wikidata, DBpedia, anything, and it's not your data, you probably want to like discover and play around a little bit to see what's there. So I'm going to show you two different Sparkle queries that you can use in pretty much any knowledge graph. You might have to change the syntax a little bit and add different namespace declarations. But this one is, this is querying for what types of things are in this triple store. So if I provided you with a public Sparkle endpoint of this triple store, this is what we got. And you can see all of the schema properties and stuff. Administrative organizations, bars, and pubs. So these are all the classes of types of things that I've modeled so far based off this project. Elementary schools, government organizations, hotels, and local businesses. The next one that I recommend you guys doing, if you don't know, would be, this is what properties are being used in this triple store. And so you can see all my schema properties, names, addresses, affiliations, birthday, death day. You can see I used the RDF type, so that that's the RDF type. And then RDFSC also. So we'll also use that to link to other things that may be related to the entity. You can see the SCOS properties, which there's very few of them. Preferred label, alternative label, close match, exact match, a note, and in scheme. And then the rest are all the Agrelon properties that we've used. Has colleague, has spouse, has child, has member, has parent, has step parent. If you guys haven't used Agrelon, I would just read the ontology just for the fun, because there's some really cool stuff like that. You want to model you've been murdered by somebody, you got a way to do it. Is the muse of, my creative muse, I can model them, it's really cool and creative that way. And then, we can all search for, you can see entities. This search here, I'm actually searching using a label to see if it contains the label, and I can see West in there. So you can see I have Dottie West, John P. West, Charles West. This one gives me back all my SCOS concepts because every entity I make is a SCOS concept, and I did that intentionally because now this linked data is interoperable. You guys could load my SCOS concepts in your Alma Primo. You could load this stuff. It's not just sitting isolated, and and this is why we use the SCOS. That question came up in an earlier session today too. We use SCOS so our data is interoperable because all of our library systems are using it. Whether you're looking at BibFrame, it's a SCOS concept, with the type BibFrame work or a BibFrame instance, or anything else. So we're using those standards to be interoperable. And then last thing I want to do, I want to show you actually how inserts work. So if you do insert, oops, let me erase that. So just insert like that. And so today I will do insert UNL colon 25632 is a schema colon high school. Has a SCOS pref label, Rancho High School, Las Vegas. SCOS note. We'll just say, oops, put in quotes. High school in North Las Vegas, Nevada. SCOS in scheme. It's in the UNL namespace. I could say schema address 19 Sears List Ave. Oh, excuse me. 1900. Type it as English. And then we could say schema alumni UNL 17559. And if you guys remember from the presentation earlier, UNL 17559, that is John P. West. So John P. West graduated from Rancho High School. There was also schema alumni UNL 27729. That is Harlan Freeman. She was also an alumni. And then that's all I have for right now. And then you can always add, oh, I should probably go add the inverse. So I'm down here. John P. West is already in this triple store, so I don't have to just declare him again. 17559. So John West, schema, alumni of UNL colon 25632. Now, I technically don't have to put the inverse in there because of my RDFS plus inference engine running, but it's my workflow. I always try to do the inverse properties and explicitly put it in there, because sometimes what if the reasoner doesn't work? What if, you have to turn your reasoner off because you're having performance issues, you know? So another caveat I recommend when working with this, I would define your entities first before making connections. I wouldn't make connections between nodes until you've already established the entity in the graph and stuff. So if I go run it, malformed at line 1, UNL schema. What did I do? Insert data. Or did I have, oh, maybe I should have data insert. No, insert. Let's see. That's all good. Yeah. So let me see. Go back real quick. All right, let me go back and just try that again. Insert data. Okay, that worked. Let's see. Why is it? It's funny how it just sometimes, and you have to debug sometimes. I've done this like a million times. Sorry, folks. I miss a closing bracket. It says it at the first line.
Someone said UNL isn't defined.
Oh, it's not defined. Yeah, so it didn't. Sometimes that's weird. Sometimes it won't put your namespaces in there. So, all right. So let me go in and just add all my namespaces. So I'll have to add SCOS. There. That's why. Normally it automatically populates when you start typing, but so when I run it, you can see it's executing. Boom, those statements have been added. So if we wanted to go search for it, we could go search. I'll put it in this query. You can see it. It's already there with the full URI with the label. And then you can see all the triples that I've encoded in there and stuff. So you can see the fourth column, that's where your name graph will go. So if you guys wanted to work with quads and set up a quad store instead of the triple store, you would just add a fourth column and then you would declare your namespace. So basically, instead of putting in the SCOS in scheme, you would put that full URL in the context column and stuff. And so now you're working with your quads and name graphs and stuff. So, wow, this is perfect timing. We are right at the clock. Do we have any questions? Any more questions right now? Because if not, I would
We
like.
do.
Oh, well, cool.
I do have a few that weren't answered in the chat. Corey's been going and cleaning up the chat and answering some questions. One of the ones that was private message is, would you speak briefly? Oh, wait, let me, before I answer this or send this question. Those of you that do want to take a break or run, the next session is in a different Zoom. The link is in the chat, so you can go ahead and go to that. But those that want to stay for questions, feel free to stay. We do have 15 minutes until the next session. So that question is, would you speak briefly about how you train students to create metadata?
Yeah, so for this project, they've been doing two things. They've been identifying individuals who would then be like the subject of a digital object. And they've been really I've done trainings with them on subject analysis. Most of the students, before they come to me, they have no experience working with classification schemes or controlled vocabularies and stuff. And so a part of the metadata training in general is I manage our metadata application profile, which has our modeling documentation, the controlled vocabularies that are required or recommended in our fields and stuff. And so we have ongoing training on that. And then before we start a metadata project, we have project specific metadata training. So we don't necessarily say, hey, here's the Library of Congress subject headings, have fun. We'll scope it for them. And based off of, the kind of classes of things that we're dealing with, I'll give them a subset to work with. And then as they go down that rabbit hole, navigating the hierarchies of broader terms or narrower terms, they'll lock in on the precision, and over time they become really really efficient with learning these controlled vocabularies.
I love using students. They are so smart. The next one, is it possible to use CSV file or drive data from it to Sparkle instead of overcoding?
Yeah, there is. If you look on the the resource page of the website, there is a Python script that I've written called CSV to RDF, I think it's called, or something like that. And basically you will have triples, a 3-column spreadsheet, and you could basically, it will convert it to an RDF file and stuff. And so if you've seen my maybe last year's LD4, it was either last year's LD4 or the year before, I did a Sparkle session, and that was also in there. And so what we did was you could use Sparkle construct, and then you could construct your triples and export it out as a CSV out of Wikidata's query service, and then use my Python script to convert it to an RDF file for you if you don't want to encode it.
And then
But
Corey actually shared that in the chat for you,
thanks.
the converter. There was a comment, these real-time examples were very cool to see. It takes a great deal of knowledge and confidence to pull it off successfully. Just wanted to share the comments.
Thank you. Thank you.
Sometimes it's nice to have those. And then Corey answered this, but they asked if it's okay if they share your activities with colleagues.
Sure. Just give me a shout out. The stuff on this website, I gave it I believe it's an MIT license. So, you guys could, use this stuff. It's, I threw this together for this presentation. So, it's here for you guys as a resource.
And we'll say the recording should be available to anyone that's in attendance that you can share to, especially if it's on YouTube. I go back all the time and look at my YouTube videos, and it shows how many people have seen it. So that's nice to track. Let's see. Is the Airtable tracker program free? Corey also answered this, but you can go ahead and answer it again. And if there's any other questions, go ahead and get them in.
Yeah, we currently use a subscription-based Airtable just because we have multiple departments using it now, and it really helps keep us on the same page.
That is all the questions I am seeing. This was great. Thank you guys for presenting this. This was awesome.
Yeah, please. And if you guys ever want to work together, or whether it's a wiki project, we are participating in the MCO early adopters phase. So we're always open to collaborate and work with folks. So
Are your slides available on Slack?
the slides are available in your scheduler, as well as a link to the website. And then it's also embedded on the website as well.
Thank you. Thank you, everyone, and I will put that next session in the link.
Thank you guys, and enjoy the rest of your conference.
Darnell, you traveled me back to grad school with this.
What?
I was back in my metadata class.
Uh,
All these schemas. I was like, oh my gosh. I remember this coding.
oh, I love it. It's fun for me. It's actually very calming.
I really like it too. I don't get to do a lot of it where I am. My library doesn't do a lot of any of this
Mm,
at all. And so when I do get like bits and pieces of it, I just really like it. I think that's why I help with this conference so much. But I really enjoy it.
yeah. No, this is my favorite conference. So I really I love this community. So
Yeah,
Yeah.
thanks so much for your help moderating and everything. It's great to have you.
Yeah, you're welcome. You took half the questions. I had to go in and start emptying out questions. I was like, sure, I got that one, got that one. So it was kind of nice.
nice.
But
Well, thank you. I'm gonna get out here and go eat some lunch. So